and welcome to this podcast for the University of Alabama at Birmingham's Research Center of Excellence in Arsenicals. My name is Mina Nabavi, and I'm a program manager in the UAB School of Public Health. Today, we are joined by Dr. Mohammad Athar. Dr. Athar is a distinguished professor and vice chairperson of dermatology in the UAB School of Medicine, where he is the inaugural holder of the Eric W. Baum, MD, Endowed Professorship in Dermatology, and is also the director of the UAB Research Center of Excellence in Arsenicals. Dr. Athar has received multiple awards, including the 2019 Dean's Excellence Award in Research. And over the past 3 years, that's 2018 through 2020, the Blue Ridge Institute has ranked Dr. Athar as the #1 principal investigator in dermatology. His background is in skin biochemistry, signal transduction, toxicology, and carcinogenesis. Currently, his laboratory is focusing on animal model development for skin cancer and skin inflammation and injury, in which his work is focused on the identification of molecular pathogenesis of the disease, molecular driver pathways, and their molecular mechanisms, employing several modern tools and techniques, including bioinformatics approaches. So Dr. Athar is here today to talk with me about the effects of arsenicals on the skin and the work of our center. So Dr. Athar, thank you so much for being here and taking time out of your schedule to talk with me today.
Thank you, Mina, for inviting me for the talk, and I will be happy to be with you and try to answer all your questions that you have today for me.
Perfect. So for our first-time listeners, can you provide a brief overview of the Research Center of Excellence in Arsenicals and what the mission of the center is?
So this is a center funded by NIH, and NIH has CounterACT program for identifying antidotes for the warfare chemicals that have been used and could be used in future, although they are not allowed to be used anymore. However, we know that in Middle East, Saddam Hussein used certain chemicals against their own people and against Iran during the Iraq War. In Syria, recently Assad perhaps used it. There are some evidences of the use of chemicals in warfare in the Middle East. So we think that we should be aware of the pathogenesis of these chemicals so that we can develop antidotes against these chemicals very effectively for unlikely use of these chemicals world over, anywhere, or in the United States. Although I don't think it may come that we really use these chemicals, but preparedness is necessary for this work.
Exactly. So the likelihood of them actually being used is slim, but I know their effects are devastating. And so since you are in dermatology, I want to ask you to share a bit how these arsenicals, and you can speak specifically about lewisite, really affect the skin.
First, I should tell you that what is chemical warfare? Chemical warfare is the use of chemical in warfare. So this is after Second World War, they disallowed use of chemicals in any warfare. However, certain countries still have stockpiles of these chemicals, and they may or may not use it. Now the question is that in case their exposure occurs in public, how can we handle the situation? So there are many types of warfare chemicals. Some affect nervous system, others affect blood. By affecting blood, I mean that they affect the oxygen carrier and lead to suffocation and death of the people. And also there are other types of chemicals which are irritants, and some of them that affect skin. are known as vesicants. Vesicants are those chemicals which, when they come in touch with skin, they cause blistering and inflammation, pain, and finally, big wounds in the skin. So, a lot of tissue damage occurs. That happens in the skin, but later on, systemic injury also occurs. And therefore, these chemicals are devastating and debilitating, and we should find a specific antidote for this kind of chemicals. So the mission of my center is to develop countermeasures for vesicants that we are using in our project. And the class of chemicals for which we are developing antidotes, they are known as arsenicals because they are developed from arsenic, which is a metalloid and very simple. It is found everywhere. The structure of these chemicals is very simple and can be developed with moderate expertise in any laboratory. So they have terrorist use angle also.
The vesicants, like you said, they're blistering agents on the skin, and you said that's when it comes into contact with the skin. Does the route of exposure affect the skin differently? And, besides blistering, are there any other impacts or symptoms?
So the way these chemicals enter into the body, particularly when they are exposed through the atmosphere, it is likely that they may be inhaled. And since they are vesicants, meaning thereby that they cause blistering, even if they go through the inhalation route, they will cause blistering in the nasal skin or the nasal tissue and in lungs. The effect will be different on the skin because the inflammatory response developed systemically will not directly cause, not likely cause blistering in the skin. However, we think that um, that both are devastating.
So, through the center, I know we have different cores that are looking at the impact on skin, the kidney, the lungs. I know we've had Dr. Agarwal to speak about the impact on the kidneys. Can you talk a bit about kind of the goal of the core that you lead, the
So my
project?
project is mainly skin project. Nonetheless, we work together to demonstrate that how skin exposure can lead to systemic injury, including lungs and kidney. Also, we are in a position to see effects on brain and liver. But since our funded project is not for brain and liver, we are not doing those studies currently. As far as skin is concerned, our major objective is to develop an animal model with which we can understand the molecular pathogenesis of these chemicals that cause blistering and inflammation in the skin, and also systemically. One major goal is to develop animal models. Then the second goal is to understand and define the molecular mechanism by which these chemicals act. And based on that, we are planning to develop certain antidotes which may be highly effective against these chemicals.
So we are in year 3 of this center and of this project. Can you talk a little bit more about some of the research around those goals that you just mentioned that are going on in your lab right now?
As far as our research is concerned, we have been able to develop two animal models. One is a murine model, mouse model, that recapitulates human pathogenesis of these chemicals. And also, we have a more relevant and closer to a human skin model, which is a porcine or pig skin model. So we have been able to develop both the models very successfully, and we showed that in the two models, it creates similar kind of damage that occurs in humans. Now, based on that, we also tried to see that what happens to individual tissues, like we showed that there is a disruption in cell-to-cell communication and tight junctions in the tissues are disrupted. Then we identified signaling which regulate this process, and we showed that if we block this signaling, we can restore those junctions. Then we also identified signaling associated with tissue damage. We found that both apoptosis and necroptosis lead to severe skin injury. Apoptosis is the initial induction of cell death process that occurs in keratinocytes and perhaps in other cells in the skin. But later on, the whole tissue is necrosed, and this is through the activation of another signaling pathway known as necroptosis signaling pathway, which is led by certain kinases known as RIP kinases. And these kinases activate this pathway that ultimately leads to tissue necrosis, or necroptosis. Then we also showed the activation of inflammatory response, and we showed that this response is robust, and this leads to activation of various immune signaling pathways. These signaling pathways are induced in order to augment tissue injury so that new tissue could be repaired or could be generated. And then some of this signaling is removal of damaged tissue from the site of damage so that the debris which is collected can be removed effectively. And then we also identified certain signaling processes, particularly associated with macrophage, that is leading the tissue repair. In addition to that, we have been able to identify epigenetic regulators of these processes, and we identified a master regulator, which is a chromatin modifier. That chromatin modifier is known as BRD4, bromodamine 4, which is a protein, and that is recruited to open chromatin so that various transcription factors could be activated. As a result, those transcription factors are recruited to genes regulating inflammation and tissue damage. If we block this signaling pathway, we could restore the damage of the tissue more effectively. So this is what we are doing so far.
Well, it's a lot. And I would be remiss if I didn't mention that, this podcast, in a few weeks, you are going to be presenting a seminar where you're going to be presenting more on this. Is that correct?
Sure.
So
we will be presenting some of our key data where we identified novel pathways that lead to such a robust injury. And we also, we will show certain data that we identified key antidotes or pharmacologically active molecules that we plan to repurpose. They are already either in clinical trials or are being used in clinic. And the advantage to repurpose is that we avoid a lot of experiments which are needed to prove that these molecules are safe, and their toxicity evaluation, which is an FDA requirement. So based on that, if we know that this molecule, which is already in clinic and has passed through the safety regulation from FDA, we can easily repurpose it for making our own antidotes. So this is what we are doing. With the Southern Research, we are developing novel agents that target the same molecular target that we have identified, and they are working on novel molecules that are in pipeline. So we have a pipeline for repurposing certain drugs, and we have pipelines for new drugs to come up that requires more rigorous examination for toxicity and for other things. So that's in progress.
now I know we're up against the clock with your time, but I just wanted to see, is there anything else that you would like to share with our listeners before we wrap up this podcast?
Well, I would say that these are the chemicals that I emphasize that might be used, but there is another angle that these chemicals may be exposed, because what happens that when in the end of Second World War, all the ships carrying these chemicals were ready to be deployed. Luckily, there was war accords, and these chemicals were not used against human population. So what they did, they dumped those chemicals wherever they were, like in oceans, they dumped all the chemicals. So they are still littering in the ocean base. And also they buried those chemicals at the site of production. So we have all around the world these chemicals littering or buried, and if accidentally they are exposed, they may lead to devastating injury. That happens quite a bit, and we know several examples, like in Japan, in China, and also in Germany, where there are many chemical exposures occur as a result of accidental damage, or as a result of excavation for building purposes, or road excavation, and so on and so forth. Accidentally also, these chemicals may be exposed. So we need to have a complete understanding by which these chemicals cause damage. We should have an understanding that what kind of antidotes we can use for the purpose of public exposure, particularly in case of larger exposures, like we see in COVID exposure. All of a sudden, such a big population exposed, and of course we were not prepared, and it took time to combat against COVID exposure. So similarly, if we see masses exposed to any chemicals because of accident or industrial accident or anything like that, it will also be devastating, and it is difficult to handle and cure those people who are exposed.
I like how you wrapped that in, from the beginning, talking about the likelihood of it happening on purpose, but the fact that these chemicals are kind of scattered all over the world, and there are, the chance that there may be accidental exposure. So this was great learning more about these types of chemicals and the work that's going on through the center, and specifically your project, to develop these countermeasures that can mitigate the arsenical-induced skin damage. So thank you so much, Dr. Athar, for being here. I'm glad we were finally able to get you on the podcast today.
Thank you so much.
And thank you for listening. Please tune in next time for another episode from the UAB Research Center of Excellence in Arsenicals.